Horizontal and vertical asymptotes represent the values that x cannot actually become, no matter how close it may get, and it may get extremely close. The output value or the input value of our function cannot ever actually reach whatever point is represented by an asymptote. So when we're trying to calculate asymptotes, for instance in the expression y equals 1 over x minus 1, what we're doing is looking for the values that x and or y cannot ever become. So for instance, if we're trying to find, let's start with the vertical asymptote. To see where the vertical asymptote is, we need to find what x cannot become. So in this case, all we need to do is look and see what value x would be that would make the denominator 0, because we can't divide by 0. So here, if we had x was 1, then we'd have 1 minus 1, and that would be 0. So the value x cannot ever be is 1. So if we draw a line at 1, that represents the number that x can never actually reach. Then if we're looking for the horizontal asymptote, so the vertical asymptote here, the vertical asymptote is 1, x equals 1, and then the horizontal asymptote, would be whatever we get when we only keep the highest powers of x. So in this case, we'd get 1 over x, so 1 divided by x, and as x gets bigger and bigger and bigger, this number gets smaller and smaller and smaller, almost to 0. As this number becomes effectively infinity, 1 divided by infinity, that's basically the same thing as 0, because this number here will get so big that the overall piece will be so tiny, it might as well be 0. So that our horizontal asymptote becomes y equals 0, or the x-axis. That's it. Okay, remember, the asymptotes are the numbers that x or y can never actually be. So in our next example here, oops, get the right tool. In the next example here, y equals 3x over 4x plus 2. The first thing we need to do is find out what would make the denominator equal to 0. So we need to find out what x would be if 4x plus 2 was 0. So we just solve this for 0, or solve this for x now. Subtract 2 from both sides, and we'll get 4x equals 2. Divide both sides by 2, and we get x equals 2/4, or 1/2. So when x is 1/2, the denominator is 0. And since the denominator can't be 0, that value then represents our asymptote. So at x equals 1/2, we have our vertical asymptote. Now we have to find the horizontal asymptote. We have to see what happens when we only keep the highest powers of x. So we end up with 3x over 4x. If we cancel those x's out, because they're the same on top and bottom, we get 3/4. So then our vertical asymptote is at 3/4. Somewhere along here somewhere. And that represents the value that cannot be reached vertically, either from above or from below, depending on the individual function.